Hello, welcome. In this short video, let us look at the distributive property of the convolution operation. So the distributive property. The distributive property basically says that the convolution of the input x of n with a sum of two impulse responses, that is h1 of n and h2 of n, is equal to the sum of the individual convolutions, that is x of n with h1 of n plus x of n convolved with h2 of n. So the convolution of the input with the sum of the impulse responses h1 and h2 is equivalent to sum of the individual convolutions, that is x of n with h1 of n plus x of n convolved with h2 of n. So let us look at the proof for this property. X of n convolution with h1 of n plus h2 of n. Now let h of n is equal to the sum h1 of n plus h2 of n. Then this convolution becomes x of n convolved with h of n, which is by definition equal to k equal to minus infinity to plus infinity x of k multiplied by h of n minus k. And since h of n is equal to h1 of n plus h2 of n, this can be rewritten as summation k equal to minus infinity to plus infinity x of k multiplied by h1 of n minus k plus h2 of n minus k. And now by simply distributing this scalar x of k to both the components in the sum, we have the summation k equal to minus infinity to plus infinity x of k h1 of n minus k plus summation k equal to minus infinity to plus infinity x of k into h2 of n minus k. And this is possible because multiplication over a sum is basically distributive. So by using that property, we are able to write the distributive property of convolution. So this is equal to x of n convolution with h1 of n plus x of n convolution with h2 of n. That is, this sum is this convolution and this sum is this convolution. Therefore, the distributive property is proven. Now let us look at the block diagrams illustrating this distributive property. That is, when we have an input x of n going through two parallel systems h1 of n and h2 of n, and then the outputs are added, that is y1 of n is the convolution of x of n with h1 of n, and y2 of n is the convolution of x of n with h2 of n, and the final sum is y of n. Therefore, y1 of n is convolution of x of n with h1 of n, and y2 of n is convolution of x of n, the input, with h2 of n. And the final output y of n is simply the sum of y1 of n with y2 of n. And the main advantage of the distributive property is that the parallel system can be replaced by a single block, that is h1 of n plus h2 of n. That gives the output y of n. So two individual blocks h1 of n and h2 of n that are basically processing an input x of n in parallel can be replaced by a single block that has an impulse response equal to the sum of the individual impulse responses. Thanks for watching.